What's up everyone, and welcome to another video. And this episode is going to be on queues, but let's just talk about stacks before we talk into queues as well, because stacks and queues follow a similar principle. So, of course, let's get into stack. So what is a stack? So a stack is a non-indexed data structure that follows the last in first out pattern. So what do I basically mean? Last in first out. So if an element gets added, it gets inserted at the top, and that's basically the element that's going to be removed first. So let's say you have to add a couple elements. You add 1, 3, and then 6, then 8. Now if you want to remove something from the stack, you have to remove an element that you recently just added. So that would be 8. If you want to remove 3, you're going to have to remove 8 and 6 as well. So that means only 1 will actually be left in the stack. So that is going to be the last in first out. So of course, let's go ahead and make a stack. So we do stack, and then let's just say any data type would be. So let's do integer, and let's call this numStack equals new stack. Now we need the tags as well, and there are 3 methods that we want to know about how to stack. So of course we need to know like the numStack.push. Now of course here the push will actually return here as return the items that are being pushed in, but it's not really what we're going for right here. Though I'm going to actually, so there we go. It's actually going to print out the integer, so it's much worth putting the toString here. So numStack right here. And then just treat them as a void method, and treat the push as a void method. That's what I'd like to do. So let's say you wanted to add 5 elements. So let's add 7, 2, let's say 5, 8, 3. There we go. Now if we were to run this, we should see that 7, 2, 5, 8, 3 should be added to the right now. So if we do numStack.pop, pop is the method of how to remove it. However, there is a remove method, however, we want to keep in mind that the bolded methods are specific to the stack here. And the search method the search method returns an integer. So, and of course, it's very complicated because stacks are usually non-indexed. So basically, we're going to focus on the numStack dot. So there's empty. Empty finds out if the stack is completely empty. Push adds an item to the stack. Pop removes an item from the stack. Peek actually prints the item at the top of the stack. And that's basically all these methods here that's necessary for the stack right here. So how do we actually print out the stack? So one way we actually did it is, of course, we actually print out the toString. But under the hood, you would actually use an array or a linked list to actually make the stack here. Now there are other ways you can do this as well. You can use the enhanced for loop. So keep in mind we need the corresponding data type for int num in numStack. Now of course we want to go ahead system.println. We got num here, and this should basically yield the same results here. So along with our array, we should be able to get all these elements while printed out on a new line. That is one way we can iterate it. So another way we can actually do this is to use an iterator. Now in the list class, we actually used a list iterator, which actually has many methods which can actually be modified. Which elements in the list iterator can actually be modified here. However, we have to use the default iterator here. So integer, let's call this iter equals. Now keep in mind that iterator is an interface, meaning that you cannot directly make an object without implementing all the methods basically. So we want to do numStack.iterator. Now I don't want to do list iterator because we Now we don't actually want to do the list iterator because, of course, the list iterator is a vector, and we want this specific to the stack. So we do iterator, and in order to actually use the iterator, you need to do while iter.hasNext, and then you want to print iter.next. The reason why we print iter.next is because the .next actually prints out the data type here. And of course, the next actually moves the cursor here. So what they mean iter.hasNext, meaning that the cursor isn't, meaning that there are no elements past the cursor. If the condition is false, meaning that there's no elements past the cursor. So that is basically going to be the same results here. So we should be able to see 72583 2 times. And there we go. That is how you iterate through a stack. So let's hop into queues now. So queues is probably going to be the big topic here. So what is a queue? So a queue is another data structure. So that's kind of like the stack. That's the main reason I got into stacks here. So queues is a non-index data structure. However, instead of following a last in first out, this will follow a first in first out. So basically, if something gets inserted first, and lots of people come before you, you get to leave first, and then all the others have to wait. So of course, we're going to make our new queue here. So there's going to be many types of queues that we're going to make. So there's two queues. There's a queue and there's a deque. So let's first talk about queues. So in order to create a queue, we need a data type. So let's just say a string, and then let's say names. We want the name list here. Now, we don't want to make a new queue because we have these brackets here. And we don't want to implement our own thing because we just wanted to show how queues work, and using the Java util is going to be enough. So instead of making a new queue with a custom implementation, we're going to use some of Java's already. Now we're going to use Java's already using, well, for some reason, well, if we try to do stack here, it's not going to work, because if we try to do stack here, even though it's not there, it shouldn't work, because stack extends vector, and vector is a list. However, if we do linked list, then we won't get an error. And the main reason is that the linked list implements both the list and the queue interface. However, we want to keep in mind that whenever we want to use linked list for only queues, we want to make sure that the beginning has queue in it instead of linked list. Otherwise, you're going to get the list methods as well, and you're going to get confused very easily. So you got pull, offer, add, you got remove, then you got remove, element, then peek, basically right there. And the bolded methods are ones that are specific to the queue, let's just say. So let's get into how to add elements to a queue. So there are two methods here. There's offer and then there's add. However, we've gotten familiar with add, that of course offer is going to be another way we can do this. And if we keep in mind that the boolean is offer here, so we do add is also going to be a boolean. So we do offer, let's just say Earl right here. And then, of course, we're going to print out the queue as well. So let's just go ahead and see how this works here. Let's just say Alejandro, Eric, let's say Aaron, and Terry. And of course, that's going to be all the names here. So notice how elements are being added to the right. Now with the stack, and now of course with the stack here, we want to keep in mind that with a stack, elements actually get removed from the same side. However, if we do the same with a queue, we use the pull method. If we do the same with a queue, notice the elements get removed from the left side, not from the right side, because I mean the elements from the left have been added first. And let's just go ahead and print out names once again. And I'm going to show you how to iterate through a queue, and I'm going to show you the various different types of queues as well. So there we go. Earl has actually been removed here. So that is how you use the offer method here. So peek actually. So peek is actually going to go ahead and retrieve the head of the queue, basically. So if we do peek, we should be able to get, after this, we should be able to get Alejandro, since that's the head. Since of course that's the current head right here. And queues are also implemented using arrays, though I find arrays more complicated than linked lists. In this case, I do find arrays more complicated than linked lists in this case here, because you have to go from the last to the first index, usually, and that's usually not that good, I should say. So I'm gonna comment the sysos, and of course, the main reason we want to do this is so that we don't get confused while iterating here. So to iterate through a queue, we want to go ahead and do named. Now of course, we could do string the enhanced for loop as well, and we should be able to get all the names here. And there we go. So that is one way we can do this. Other way, we can use an iterator. So that is going to be the string. However, keep in mind that the iterator here has the same data type as the queue here. So that's going to be the name iter equals, now we do names.iterator, and like we did with our stacks, we need to do while name iter dot has next. And we're going to print out name iter dot next here. As well, next advances the cursor, so you'll not be stuck in an infinite loop here. And we actually get all these twice here. So that's basically how to iterate through a queue. Now let's talk about double queues as well. So deke. So in order to actually do the deke here, so this is a deke. Let's just say we want a number, integer, num queue, and that will be equivalent to new. Now we don't want deke, since deke is also an interface. So however, we want to keep in mind that we can either set this to a linked list or an array deke. An array deke basically uses an array as a queue, basically. Like array list uses an array as a list, array deke uses an array as a queue. For adding to a queue, so of course, actually it's going to be num queue. So let's start. Now of course we got add, and then there's many different methods. So we got add first and then add last, which are void, which is going to be void here. So of course, then we got offer first and offer last. So that is definitely going to be something like that. So then you got pull first and pull last, remove first, remove last. In addition, there's many methods here. Remove first occurrence, remove last occurrence here. And then of course you got the size as well. So that's actually going to be a lot of methods here. So let's go ahead and offer some methods here. It just adds to the head. However, we can do offer last. And let's just go ahead and print out the queue as well. So if you understand queues, you can also understand deques as well. So you got 4 and 7. And of course, this is basically a priority queue as well. So something else before I go, there's also a class called a priority queue. So however, you want to keep in mind that the priority queue only implements queue and not deke. So priority queue is going to be new priority queue. That is going to be this. So elements are inserted in position based on priority. So that is based on .add. So that's going to be add.offer. And then you got offer. You got 3. And let's say you want a couple of numbers here. So let's say you got 1, 9, 5, and 7. Now let's go ahead and print out the priority queue. As well as we're going to remove all of these. So of course we got 3, and then you got 1 here. The priority queue prints out 1, 3, 9, 5, and 7. So that is basically this. So basically, how will priority queue remove? Priority queue follows a unique system, which of course you can't remove from the beginning and the top. But anyway, guys, we'll talk about priority queues later. So if you guys enjoyed, leave a like, subscribe, and see you in another vid.